Good morning, everyone. My name is Ken Lee. I'm Director of Engineering and Research at the Pipeline Safety Office at PHMSA. I'd like to thank everyone for attending here, and we are looking forward to your active involvement in our event. We have 4 talks this morning by Government and Pipeline Safety Trust. We're going to break for lunch. And then we have talks this afternoon by 3 pipeline operators and a panel discussion. To start off our first talk, we have Robert Hall. He's from the National Transportation Safety Board, Office of Railroad, Pipeline, and Hazardous Material Investigations.
Thank you, Ken. I'm Robert Hall, the Director of Railroad, Pipeline, and Hazardous Materials Investigations. At the NTSB, those of you that may not be familiar with us, we conduct independent investigations of accidents and make safety recommendations, and safety recommendations is our primary product. At the board, we normally have 5 board members. We currently have 4. There has been another one nominated but has not yet been confirmed. Our board members are currently Christopher Hart, who's the chairman. Christopher Hart was the vice chairman before becoming chairman. The Honorable Bella Dinzar, who's our vice chairman. She was just appointed and confirmed by the Senate. Member Dinzar has a background in highway. Christopher Hart has a background in aviation. Then we have the Honorable Robert Sumwalt. Again, he has a background in aviation, and the Honorable Earl Weiner, who also has a background in aviation. The board has tended to be kind of aviation-centric for many years. Our nominee that's coming up that's awaiting Senate confirmation actually has a background in rail, so we'll have start to have a more diverse board. I look forward to the day that the board finally has a member with a background in pipeline. I want to start with a couple of questions, with a short quiz, and those of you that were at the Western Gas Conference can't answer these questions because we use the same quiz out there, but how many NTSB pipeline reports did we issue in 2015? Anybody hazard to guess? The NTSB folks in the audience can't answer either. Well, the answer was 2. Early in the year, we issued a safety study, and safety studies are one of the products of the board that tend to be data-driven. Our safety study focused on gas transmission integrity management. There's a lot of lessons in there for liquids. That safety study also had a number of recommendations, some of which do affect the liquid side as well. There were a whole series of recommendations in that safety study dealing with the National Pipeline Mapping System, which is both liquid and gas. So we gave PHMSA a new pile of tasks to work on. And speaking of that pile of tasks, how many safety recommendations related to pipeline safety did we issue in 2015? Only 2 reports, but we issued 28 safety recommendations for pipeline safety. There were some other recommendations that came out of our pipeline reports, but they weren't specifically for pipeline safety. They tended to go to the emergency response community after the fact that we're trying to prevent. I was asked to talk a little bit about NTSB's perspective on integrity verification. And if you research the NTSB recommendations, you'll find that we've only ever issued 1 recommendation dealing with integrity verification. And that recommendation came out of the San Bruno accident. And I'll let you know, if you have questions about San Bruno, our investigator in charge, Ravi Chatra, is right here in the audience. So feel free during the breaks, if you have questions about San Bruno, to hit up Ravi for answers. So he's led one of the largest pipeline investigations that NTSB ever did. But that recommendation that came out of the San Bruno, and I have a slide here with kind of some of the keywords, but I'll actually read the entire recommendation because this is the start of integrity verification. Aggressively and diligently search for all as-built drawings, alignment sheets, all specifications, and all design, construction, inspection, testing, maintenance, and other related records, including those records and locations controlled by personnel or firms other than Pacific Gas and Electric, relating to pipeline system components such as pipe segments, valves, fittings, weld seams for Pacific Gas and Electric, natural gas transmission lines in Class 3 and 4 locations and Class 1 and 2 high consequence areas that have not had a maximum allowable operating pressure established through prior hydrostatic testing. These records should be traceable, verifiable, and complete. That recommendation was fairly limited. We looked at those high consequence areas. We looked at those things that were not hydrostatically tested. In the subsequent to that recommendation being issued, which was issued in, I believe it was December of 2010, when the report came out later that year, we also made a recommendation to eliminate for the gas side the grandfather clause to ensure that pipes that had not been hydrostatically tested got hydrostatically tested. When we looked at Pacific Gas and Electric in that investigation and we looked at their records were horrendous, absolutely horrendous. And in the report, it'll document some of the failures. But the pipe segment at the location of the accident was listed as 30-inch seamless. There was a problem. 30-inch seamless wasn't made in 1956, and that was the date of construction of that segment. I mean, it was a glaring error. Seamless pipe in that size is kind of unusual in pipelines anyway. So, you know, it had that glaring error. There was pipe listed as type B with specified minimum yield strengths far in excess of what type B is. I mean, up to 48,000 and 52,000, but it was listed as type B. You know, so many, many problems. And we went through just for line 132 and documented literally thousands of data errors in their data. We went through, I think it was in excess of 40,000 pages of documents that PG&E had, and found many things that PG&E wasn't aware of. The original construction of line 132 occurred in the late 1940s, and they hired Bechtel to do the construction. Bechtel actually had tremendous construction records, and we went through those and found history of seam problems. PG&E didn't think they had seam problems, but there it was in construction, radiographs, seam problems, cutouts, repairs from the construction. The segment where the failure occurred, which was a segment that happened to be relocated by PG&E themselves, their own internal construction group, the records were virtually non-existent. Which is kind of interesting. That occurred in 1956. So you have 1948 construction, you hire a contractor, huge amount of construction records, very detailed, very accountable. You do the project yourself and you don't keep any records. So there was a problem there. One of the things that I think San Bruno, the lesson that it told for all of us, and you know, after San Bruno, we issued this recommendation just to PG&E, but I can tell you the whole industry took notice and the whole industry was hiring pipeline engineers to go through records. In fact, we were getting questions on the recommendations, and this kind of took us by surprise at first. You know, people were asking for interpretations of our recommendation, and it's like the recommendations to PG&E, but they were being very proactive, and that's one thing where the industry really stood up and started to realize that there was a fundamental problem here with the way business had been conducted for years, and started looking at it. But there's three things that I come down to when we think about hazardous liquids and integrity verification. Those three things: know what you don't know. And that's a hard question to answer. And PG&E has spent millions trying to know what they didn't know. But it's important. You've got to know the system, because what you don't know is where your failure is going to occur. What you don't know is where your problems are going to be. That piece of pipe that's undocumented, that's in the system. You need to find what you're not looking for. And this is in our report that came out in early this year, our pipeline safety study. We finally made a recommendation to eliminate the use of direct assessment as a sole means of integrity verification. And we have a fundamental problem, at the NTSB, we have a fundamental problem with direct assessment. Direct assessment finds problems you're looking for. If you compare that to inline inspection or hydrostatic testing, inline inspection and hydrostatic testing find things you're not looking for. Yes, you go into those inspections looking for specific issues and testing specific risks, but you always find things you're not looking for because you look at the pipe from one end to the other. You find anomalies in your inspections, your inline inspections that you're not looking for. And so you really always have to be looking for what you don't believe is there. You have to do a complete integrity assessment. And with the liquids, kind of the last fundamental thing here, think leak. And I say this because you look at the investigations that the NTSB has done, from Olympic to Colonial at Fork Shoals to Marshall, Michigan. What's the common thing in every one of those major accidents? The controller turned the pumps back on after they had a leak. And each of those accidents was made tremendously worse by that action. You've got to think leak. You've got to believe your indications. Marshall, Michigan, they had an alarm, told them there was a leak. They had that alarm when they turned the pumps back on, told them there was a leak. And they had the alarm when they turned the pumps back on the second time, told them there was a leak. Didn't believe their indications. And actually they came down to, well, you know, if there had been a leak, somebody would have called us. You know, you can't rely on the public to report your leaks. So you always have to think leaks. With that, I'm going to turn it over to Steve, who's going to give the PHMSA perspective, and then I guess questions will be after Steve gives his talk. Thank you.